Welcome back, everyone. I am absolutely thrilled to have you here for this explainer. Today, we're undertaking an incredibly exciting, rigorous mathematical tutorial that aims to do nothing less than decode the quantum fabric of the universe. We are going to explore exactly how the Adelic Langlands Program provides this radical geometric framework to finally resolve Connes Embedding Problem. If you love deep mathematics and fundamental physics, you're definitely in for a treat today.
Okay, let's dive right in. Here is our roadmap for today. 1. The core obstruction. 2. The Adelic lift. 3. The p-adic trace. 4. Jones index scaling. 5. The holographic area law. And finally, 6. The absolute hologram.
Section 1. The core obstruction.
So to really understand the solution here, we first need to look at the problem. Connes Embedding Problem essentially asked whether all macroscopic, continuous quantum observables could be approximated just by scaling up finite, discrete digital systems. Well, in 2020, the landmark MIP RE result mathematically disproved this. When you examine these wild operator algebras, these highly entangled quantum systems, they possess correlations that simply escape the reach of standard classical complex matrix spaces. It literally revealed a hidden topological defect that just cannot be smoothed out or approximated by our standard, continuous Archimedean math.
So the crucial point is that we must completely shift our framework. If we look at this system strictly through a single, continuous Archimedean window, using just real or complex numbers, it looks like an infinite-dimensional, chaotic failure. The classical trace just doesn't have enough information to capture the full entropy. But if we shift to Adelic field theory and embed the problem into the global Adele ring across all primes simultaneously, what looked like an unresolvable defect is actually revealed to be a global arithmetic ramification profile. The matrix is perfectly conserved.
Moving on to Section 2. The Adelic lift.
Let's examine equation 1, the Adelic Connes embedding map. Instead of restricting our approximation to matrices over just complex numbers, the Adelic Langlands program lifts the entire system to matrices over the local fields across all primes simultaneously. We can see the wild type 2i1 factor m embedding directly into the restricted product across all fields, which yields the Adelic hyperfinite ultraproduct. By lifting these wild algebras into a global Adelic ultraproduct, we essentially regularize those quantum anomalies through global wave harmonics.
Now, the mechanics of this Adelic lift happen in 3 really beautiful steps. First, we decompose the non-commutative trace, which forces those anomalous correlations to distribute their information across finite prime channels. Second, using functoriality, we map these spectral states to automorphic dual spaces. This is where seemingly unapproximable singularities map onto discrete, stable matrix eigenvalues. And finally, the Adelic ultraproduct convergence enforces a strict local global conservation law. So, that missing Archimedean data? It's conserved perfectly as an arithmetic accumulation of p-adic conductors.
Which brings us to Section 3, the adic trace.
Now, what's really fascinating about this next piece, equation 2, the explicit p-adic tracial component, is how we mathematically capture those non-local entanglement anomalies. On one side of the equation, we have the localized p-adic normalized trace evaluating information. On the other, the sum evaluates the discrete concentric shells of ultrametric space. The missing information hasn't magically vanished. It just leaked out of the continuous real numbers and condensed entirely here, into the non-Archimedean sectors.
An absolutely vital variable in that last equation is the conductor exponent, denoted as Fp. Mathematically, it sits right at the top of our summation. But physically, this acts as a strict boundary condition. It's literally the absolute ceiling that cuts off infinite dimensional growth. Because of this exponent, those wild, highly entangled quantum strategies are forced to stabilize into a finite, rational combination of local fields.
And this brilliantly illustrates how the Brouhat-Titz tree trap structurally shields against that divergence. Continuous spaces try to smooth out infinite-dimensional entanglement, which inevitably leads to this uncontrolled growth. But the p-adic hyperfinite factor completely avoids this, because its strong triangle inequality creates an ultrametric shield. It mathematically traps those wild correlation paths into discrete, stable, concentric shells branching outward on the tree.
Section 4, Jones index scaling.
All right, here's equation 3, the Adelic Jones index scaling invariant. Now, in classical theory, the Jones index measures the relative size of a subfactor, but here we lift it to our localized Adelic subfactors. This equation shows how the local Jones index subfactor coupling explicitly anchors spatial dimensions, meaning the actual physical mass, scale, and volume of the dual prime fiber, directly to discrete algebraic values.
The physical fallout of this equation is just staggering. It tells us that spatial quantization isn't some arbitrary cutoff we invented. It's the direct macroscopic projection of operator subfactors. This math dictates the mass gap, forcing rigid quantized rest masses on elementary particles. And honestly, most importantly, it completely eradicates geometric singularities. Because the discrete Jones index has an absolute minimum floor of 1, physical volume can literally never vanish to absolute 0. This graph of the geometry of subfactors maps this out so perfectly. Take a look at the boundary at index 4. Below 4, the index is strictly mathematically quantized into a trigonometric series, those discrete points. But above 4, it transitions into a continuous hyperbolic band. The universe mathematically forbids intermediate spatial dimensions below the index of 4, forcing a discrete, quantized spatial fabric at the absolute deepest foundational levels.
Section 5. The holographic area law. Let's move on and see how this geometric framework builds directly into equation 4, the Adelic holographic area law. In semi-classical gravity, black hole entropy is just area over 4g. But this equation gives us an absolute unitary area law that subtracts an exact microscopic arithmetic correction, utilizing exact Riemann or Dedekind zeta function thermodynamic corrections, evaluated right at the J-theory spectral boundary.
So, what we are essentially doing here is a two-step process across the horizon interface. First, we evaluate the Archimedean continuous macro area term, what we typically think of as the smooth geometry of the horizon. Second, we subtract the p-adic microscopic arithmetic error correction. We always assumed subleading corrections to black holes were just these vague quantum loops, but this proves they are exact arithmetic invariants driven entirely by prime numbers. Notice how the famous black hole information paradox is completely resolved here. If you only look through the continuous Archimedean lens, divergent entanglement overflows the capacity of smooth real numbers, and the data appears lost. But when you shift your perspective to the Adelic ultraproduct, it proves this missing data is actually perfectly preserved inside the ultrametric tree states of the non-Archimedean sectors. The total information remains in absolute invariant balance.
Section 6. The absolute hologram. Ultimately, what does this all mean? It means that what we perceive as a smooth, continuous spacetime background is merely a semi-classical shadow. The true substrate of the universe is this stable Adelic matrix. When a quantum system gets highly entangled, it expands its information budget out of analog real numbers and uses discrete p-adic error-correcting codes. It is all anchored to rigid, absolute number-theoretic geometry.
We've covered some incredibly heavy mathematical ground today, so let's celebrate a bit by quickly reviewing the 4 elegant pillars we just traversed. We saw the Adelic lift regularize quantum anomalies. We saw the p-adic trace mathematically trap entanglement in ultrametric shells. We saw the Jones scale invariant forbid geometric singularities. And finally, we saw the Adelic area law resolve the information paradox through exact thermodynamic corrections. These 4 pillars literally rescue quantum reality from infinite chaos.
Which leads us to our final, breathtaking conclusion. If these operator anomalies are completely regularized by the primes, then chaotic infinite divergence is merely an optical illusion caused by looking through the wrong mathematical window. It turns out, our universe is a perfectly conserved, absolutely balanced information matrix. I really hope this deep dive into Logos field theory has completely reshaped how you view the fabric of continuous reality. Keep questioning, keep exploring the math, and thank you so much for joining me on this explainer.